Namaste, and welcome back to JEE Mathematics with Typical Monk. This is class 18, differentiation. Zoom into any smooth curve far enough, and it straightens into a line, and the slope of that line is the derivative. It tells you how fast a quantity is changing at a single instant. Today, we gather the rules, product, quotient, and the all-important chain, and use them to differentiate the implicit, the parametric, and even x to the power x. One idea at a time. Here is what you will learn today. First, the derivative as a slope and the standard functions. Second, the product, quotient, and chain rules. Third, implicit and parametric differentiation. Fourth, logarithmic differentiation, the x to the power x type. And fifth, higher order derivatives, plus the drills. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The derivative, dy by dx, is the slope of the tangent, the instantaneous rate of change of y with x. The standard forms. The derivative of x to the n is nx to the n minus 1, of sine x is cosine x, of e to the x is e to the x, of natural log x is 1 over x. The chain rule. Differentiate the outer function and multiply by the derivative of the inner di by du times du by dx. And the product and quotient rules. For a product, u dash b plus uv dash. For a quotient, u dash v minus uv dash all over v squared. Now look at the picture. The derivative as a slope. The derivative is a slope. dy by dx at a point is the slope of the tangent line drawn there. From secant to tangent, as delta x tends to 0, the secant line through two nearby points swings around until it becomes a tangent. Rise over run. The slope is the limit of delta y over delta x, and the steepness of that tangent is exactly the derivative. A rate of change. That same di by dx measures how fast y changes with x at that very instant. Now, the rules of differentiation, the tools you use again and again. The ribbon holds the anchors, the product rule, the chain rule, and the power rule. The product rule. The derivative of uv is u dash v plus uv dash, differentiate one, keep the other, and add the two. The quotient rule. The derivative of u over v is u dash v minus uv dash, all over v squared, and the order in the numerator matters. The chain rule. For y equal to f of g of x, dy by dx equals f dash of g of x times g dash of x. Never forget that inner derivative. And the standard forms. X to the n gives nx to the n minus 1. Sine x gives cosine x. E to the x gives e to the x. Natural log x gives 1 over x. And a to the x gives a to the x times natural log a. Let us work 3 derivatives by 3 methods: implicit, parametric, and logarithmic. The implicit one. Differentiate x squared plus y squared equals 25, term by term. 2x plus 2y times dy by dx equals 0. Solve. So dy by dx equals minus x over y. Every y differentiates with a dy by dx attached to it. The parametric one, x equals a t squared, y equals to a t, so di by dx equals di by dt over dx by dt, that is 2r over 2t, which is 1 over t. The logarithmic one, y equals x to the power x, take the natural log y equals x log x, differentiate 1 over e times dy by dx equals log x plus 1. So the answer, dy by d, x equals x to the x times bracket 1 plus log x. 3 methods, 1 idea, differentiate carefully with the chain rule included. Now the picture behind the chain rule, a composite function in layers. A composite function, y equals sine of x squared. An outer function, the sine, wrapped around an inner one, x squared. Peel the layers. Differentiate the outer function with the inner left sitting inside, then multiply by the derivative of the inner. So d by dx equals cosine of x squared times 2x. The cosine keeps the x squared inside it, and the 2x is the inner derivative. And in symbols, di by dx equals di by du times du by dx with u the inner function. Miss the inner and you lose the marks. Now what JEE actually asks. 5 pointers. 1. The derivative is a slope of the tangent and the rate of change written dy by dx. 2. The standard forms x to the n gives nx to the n minus 1. Sine gives cosine, cosine gives minus sine. E to the x gives e to the x, natural log x gives 1 over x. 3. The product rule, derivative of uv is u dash v plus uv dash. The quotient rule, derivative of u over v is u dash v minus uv dash over v squared. 4. The chain rule, dy by dx equals f dash of g of x times g dash of x. Implicit, where each I carries a dy by dx, and logarithmic for the x to the power x type. And 5. Parametric, dy by dx equals dy by dt over dx by dt. And the second derivative needs the parametric formula, not d2 y by dt squared over d2x by dt squared. Now a true or false drill. For each claim, decide if it is true, and if it is false, find exactly where it breaks. Claim 1. The derivative of sine of x squared is cosine of x squared. Novice, cast is false. You must multiply by the inner derivative, giving cosine of x squared times 2x. Claim 2. The derivative of x to the n is nx to the n minus 1. That is true. The power rule, straight and clean, for any real n. Claim 3. For x equal to f of t and y equal to g of t, d by dx equals dy by dt times dx by dt. That is false. It is the ratio dy by dt over dx by dt, not the product. Now match each function to its derivative. The derivative of e to the x goes to e to the x, gave all. The derivative of natural log x goes to 1 over x. The chain rule goes to di by du times du by dx. And the parametric dy by dx goes to dy by dt over dx by dt. 4 pairs, each worth committing to memory. Now, how many of these 3 statements are correct? 1. The derivative of a constant is 0. That is correct. 2. The derivative of sine of x squared is cosine of x squared. That is wrong. The chain rule adds a factor of 2x. 3. For y equal to x to the n, dy by dx equals nx to the n minus 1. That is correct. So the answer, 2 are correct. Statements 1 and 3. The trap is statement 2. The chain rule adds a factor of 2x to the sine of x squared. Now the 2 mistakes that quietly cost marks. The myth, the derivative of a composite f of g of x is just f dash of g of x. The truth, you must multiply by g dash of x, the inner derivative, that is the chain rule, and forgetting the inner derivative is the commonest slip of all. The second myth, in parametric form, d by dx equals dy by dt times dx by dt. The truth, it is the ratio dy by dt over dx by dt, and the second derivative needs its own formula, not d2i by dt squared over d2x by dt squared. Now, test yourself. Answer in your head before the reveal. That is how JEE speed is built. Here we go. Question 1. The derivative of x cubed, 3x squared. Question 2. The derivative of e to the x unchanged. Question 3. The derivative of sine of 2x. By the chain rule, 2 cosine of 2x. Question 4. dy by dx for x squared plus y squared equals 1 minus x over y. And question 5. The derivative of natural log x, 1 over x. Let us gather it all in one breath. The derivative is the slope of the tangent and the rate of change. The standard forms: x to the n gives nx to the n minus 1, sine gives cosine, e to the x gives e to the x, natural log x gives 1 over x. The product rule: u dash v plus uv dash. The quotient rule: u dash v minus uv dash over v squared. The chain rule: di by dx equals f dash of g times g dash implicit. Attach a di by dx logarithmic for the x to the power x type. Parametric: dy by dx equals dy by dt over dx by dt. Next class: the applications of derivatives, tangents and normals, and maxima and minima. The derivative is nothing but the slope of a curve caught at a single point, and armed with the product, quotient, and chain rules, you can differentiate almost anything, implicit or parametric, even x to the power x. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack JEE. I will see you in the next class.